Hello, this is checkpoint 4.33. They want us to calculate the directional derivative of f of x, y, z in the direction of negative 3i plus 12j minus 4k, and we have the given function. So we know that the directional derivative is simply the dot product between the gradient and u. But the important thing to note is that u has to be a unit vector. And just by looking at this vector here, it does not look like a unit vector yet. So we'll need to fix that up. Let's find some derivatives first. Well, let's make this into a unit vector first. So we have v is equal to negative 3, comma 12, comma negative 4. Let's make that into a unit vector by dividing by its magnitude. So we need its magnitude. So the magnitude of v is going to be the square root of 9 plus 144 plus 16. So that's 25 plus 144. It becomes square root of 169, which I think is 13. Okay, so that turned out to be a nice number. Therefore, our u vector should be equal to, let's just keep the 1 over 13 out in front. That's negative 3, 12, negative 4. I mean, we can take the 13 and divide each one by 13, but let's just leave it like that. Okay, now that we have the unit vector, let us find our derivatives. Our f sub x, derivative with respect to x, is going to be, looks like it's going to be 6x plus y. And the third component's gone, the fourth component's gone, z, and then the last one is going to be 2z. Okay. We'll want to evaluate this eventually at the point 0, negative 2, 5, f sub x of 0 and negative 2, 5. So 0 in for x, negative 2 in for y, and 5 in for z. So it looks like we're going to get an 8 for the first component when we put it together. Next, f sub y. With respect to y, the first component's gone, the second component is just x, and then we have a negative 4y plus 4z, and there's no z, there's no x's in the last two components, so this is all we have. Again, we'll put 0, negative 2, and 5 into this derivative. So 0 in for x, negative 2 times negative 4, that's positive 8. And 4 times 5 is 20. We get 28 for our next term. And then f sub z will equal to, with respect to z, the first two components, 3 components are gone. The first one that comes up is 4yz. With respect to z is 4y. And with respect to z, negative 2z plus 2x. Negative 2z plus 2x. All right, we'll put in those points again, or that point. F sub z will equal to, or f sub z of 0, negative 2, 5. 0 in for x, the last component, so the last term's gone. Negative 2, so that's negative 8. And 5 in for z, so that's negative 10. Looks like we got a negative 18. Okay. All right, now first let's find the derivative of f in the direction of u of just generically x, y, z, and that is just this is parentheses. It's not a vector. It's an actual number. So we get a 6x plus y plus 2z times the first component of the unit vector, negative 3 over 13, plus x minus 4y plus 4z times the second component of the u vector, and then I'll have to add this down here, 4y minus 2z plus 2x, and that will get multiplied by the third component, which is negative 4 over 13. Okay, finally let's do the directional derivative of u, or the directional derivative of f in the direction of u. This time we're going to evaluate specifically at 0, negative 2, 5, and that would be 8 times 3 over 13 negative plus 28 times 12 over 13 plus, and then we have a negative 18 times negative 4 over 13. Okay, so you can go ahead and simplify this, and you should get a scalar value for this problem. Okay, I hope that helps.